A confidence interval is a estimation so that you can have your mean. If you just stated your mean, that would be a point estimate. But you can't be terribly sure that a sample mean is going to be really exactly equal to the population mean because we've selected a sample. It's going to be a smaller group than what originally you had. So somebody very wise came up with the idea of giving a little margin of error. So within 3 points, the polls say that everybody loves Obamacare. That would be the idea of a confidence interval, where we were saying giving a margin of error. So the level of confidence is a letter, we often call it C, and it is a probability that your interval estimate will actually contain your true population parameter. So here's a picture. C is an area in the middle of the population curve. So it's between two critical values that in this case are Z-scores. And the idea will be that we'll have a certain confidence level, a percentage, that we are wanting to talk about. So the critical values are Z-scores. There's a negative and a positive because the normal curve is symmetric. And so whatever happens on the left also happens on the right. This is a Z, so that the mean here is 0. These are not raw scores. These are standardized scores. So Z is 0. So if your critical values are here at negative and positive Z, then the remaining area in the tails is going to be 1 minus this confidence level, okay? And that area in the tails is going to be alpha. The two tails make up alpha. So we're going to use the standard normal table or this ALEKS calculator to find these values. So for example, if the level of confidence is 90%, this means that we're 90% confident that the interval we create contains the true population mean, mu. So here is a curve, and if 90% is here in the middle, that means C is 0.90, and the area in the tails is 1/2 on each side because there's 2 of 1 minus C. So 1 minus 90, 1 minus 0.90 is 0.10, and 0.10½ is 0.05 for each side. So then, using the ALEKS calculator, and I'll show you that in just a minute, you would find that your Z-scores are positive and negative 1.645. Okay, so here is the ALEKS calculator. So here on the calculator we have a Z with a little box next to it. If the tail is 0.05, then that is the alpha level that is shaded here on the right. So all I need to know is the percentage or the part of the curve that's in the tail, in one tail. And that's the number that I'm going to put into the little box in ALEKS, in the Z. So then when I click enter, I'll get the Z-score is 1.645. Okay? Now, the negative, if we're talking about the lower half, we have a negative Z, which is negative 1.645. If we're talking about the upper half, then that would be Z, and Z then equals positive 1.645. Okay? And you can use actually either one to get the answer. Okay. Now, one of the calculations you have to make in order to find the confidence interval is the margin of error. Now, the margin of error is the greatest possible distance between your point estimate, which is the mean, which is, I'm going to try and write it here, mu, and the value of the parameter it is estimating. Okay? So the point estimate is actually X bar. Sorry about that. The point estimate is your sample mean, and the value of the parameter it is estimating, that's mu, is the parameter for a given level of confidence. Okay? Then we call the margin of error E. So the formula for E is that critical value of Z that we found a minute ago times the standard error, which is the standard deviation of the sample means, which is calculated by your critical value times the standard deviation over the square root of the sample size, where n is your sample size. If n is greater than 30, you can use the sample standard deviation, which is given by the letter S, if you don't have sigma. Remember, sigma is the population value, and S is the sample value, and both referring to standard deviation. Writing with a mouse is not that easy. Okay? So sometimes it's called the maximum error of estimate or error tolerance. So looking at a problem from one of your topics in ALEKS. This is the name of the topic. It's the confidence interval for the population mean use of the standard normal. So a laboratory in Alaska is interested in finding the mean chloride level for a healthy resident in the state. A random sample of 150 healthy residents. So what is the 150? That is our letter N. Healthy residents has a mean chloride level of 104. I don't know what that means. Okay, so this is the sample mean. So 104 is your X bar. Okay, 104 is your X bar. If it is known that the chloride levels in healthy individuals have a standard deviation of 40, okay, so that sigma is 40. Find a 95% confidence interval for the true mean chloride level of all healthy Alaska residents. Then complete the table below. The question is, what is the lower limit and what is the upper limit of the 95% confidence interval? So to do that, we have the formula. Okay, using the explanation that's in ALEKS for this problem, they call it Z, where I usually use Z critical, the critical Z. They put Z sub alpha over 2, and alpha equals 1 minus C. So in our problem, alpha was 1 minus 0.90. And so 1 over 2, alpha over 2 is the point, oops, not 90. Where's my pen? .95, and so alpha is 0.05. So you're actually going to put in 0.05 divided by 2 is 0.025. And that's what you'll use in the ALEKS calculator. Okay? And that answer will come out as 1.96 for your critical Z. That's what we'll use for Z. Okay? So, did I go two-step? No, that's fine. So, the confidence interval is, see here, here's the mean. This is the population mean. And this is saying that the two less than symbols is saying that The true population mean is between the mean minus the margin of error and the mean plus the margin of error, where E is that critical Z times sigma over the square root of n. So now in our problem, X bar was 104. Let me, hang on one second. I have a decimal point in the wrong place. There we go. X bar is 104, and our margin of error okay, I did do this on, what happened? Oh dear, I wrote all in the area. I don't know how to get this out now. I've saved when I went out to make that one correction on the .04, they lost the ability to erase my my scribbling here. So anyways, the margin of error is that Z, 1.96, times 40 over the square root of n, which was 150. So that's 1.96 times 40 over, the square root of 150 is 12.2474. So 40 over that is 3.2660. So 1.96 times that rounds to 6.40. So that is E, which is your margin of error. So then on our confidence interval, we've already calculated our E, and X bar is 104. E is the margin of error is 6.4. So your confidence interval is from 104 minus that margin of error up to 104 plus that margin of error. So the confidence interval is 97.6 to 110.4. So your upper limit is 110.4 and your lower limit is 97.6.